artificial intelligence primarily on the edge devices. Internet of Things is kind of a buzzword, but most of the things that what we do, so I'm representing the company Open Consulting, that's just on the legal side, and uh, the main thing that we deal with mostly is edge devices. So what kind of edge devices? If you look at it, is in the just in London itself. Uh, Look at the CCTV cameras. There are like approximately 500,000. This is data back in 2010, and that's the number of cameras which are out there, which are continuously recording and doing what they're supposed to do is monitoring the bad activities. But this is the sad reality of it, that you've got too many cameras and too less people looking at them. And say if this is just a typical CCTV center, or basically a monitoring center, and if one of this guy goes on a loo break, just imagine what is the pressure on the other guy to look at and how many cameras that person has to cover. It's practically impossible for a human being to cover all the cameras 24/7. And this is a typical infrastructure in any kind of organization. It could be a supermarket, it could be a council, it could be your organization, which is trying to prevent theft or to prevent crime. If we look at the edge devices, what kind of edge devices are we talking about? Cameras are the most common ones because there are like billions of cameras across the globe which are being recorded. But that's not the only thing. We have got smart bulbs, we have got security systems, we have got your home alarm, which is also quite smart now. We've got smartphones, which are an edge device with a camera, with a microphone. So they are actually an edge device, and they are spread all across most of the retail industry. You have got cameras monitoring, you've got Bluetooth scanners spread all across the floor. You've got, if you go into the construction sites, you've got all kind of sensors for checking for fire alarms. You've got sensors for various things. And these are all running on the edge. And when it comes to doing things, they barely do anything on premises. And most of the enterprises unknowingly are sending their data across to cloud. A simple example would be a doorbell or a camera monitoring app which you can install on your phone. All those things go through a cloud network. And AI, artificial intelligence, as everybody wants to be, is being used across everywhere. It's like undeniable fact that it's being used for access control, wherein you can have facial recognition or fingerprint scanning. It's also used for public transit, international industrial inspections as well, wherein you're looking at a thermal image of an object, or if when for traffic engineering, like basic traffic management or traffic signal control. You've got a retail area as well, which is primarily looking at the kind of traffic flow into the organization, logistics, critical infrastructure. So that's another area which is heavily, I believe most of us in this community are aware of. That needs, the more expensive your jewel is, the better you want to protect it. And the next one is the public safety, whereas how people are doing. So AI is used everywhere. Why are we moving things across, moving the AI onto the edge? Because AI is quite expensive and power consuming. I mean, if you as a human being are looking at this picture, you can easily see that there are so many people out there. There are buildings, there are people who are riding on a bicycle. But teaching a computer to be able to identify all these things and take an action based upon that is what I believe the AI is all about. It's not just being able to identify things, is being able to do something with that particular information. And that's what my area has been for the last couple of years, is primarily making the AI more actionable? Can I do something with that piece of information which we have gathered together? And this is just a typical example of one frame. So frame is basically, if you're looking at a video feed, one video feed generally has got, like, if you hear 30 frames per second, so you're actually processing 30 different frames per second. You need a quite beefy computer to do this. And when you only want to do it on the edge, you can't just put servers on next to every camera which is out there. So you need to be quite smart into what kind of solution you are building out in there. And so what kind of work we do is primary things like facial recognition. Pretty much everybody knows about these kind of things. Is so looking at an image, trying to identify if that is a person, and also being able to recognize that person, whether that person should be allowed inside the building, or does that person has a criminal activity or a background. Can we do a match and avoid that person, or maybe alert immediately? Then the new things with COVID-19 is now we have got masks, and that's a big challenge in itself, because masks have reduced down the inference capability of all of the machine learning or artificial intelligence that we have been doing. And apart from that, we have been working on a lot of great tools to, and the best part about all artificial intelligence is most of the things are open source and they are available freely on the internet. So things is just people are continuously building on top of what other person has already done research. And there are already tools which are out there which can look at your picture and they can tell that this is a female who has got age group, and an approximate age group based upon the skin type is a young woman, ethnicity is Caucasian, body part, human face is visible, and also you can see what kind of hairstyle they have got, what kind of build. And I'll just give a simple example. If there is a crime which happens out there, and you have to give a description of the person who committed that crime, you as a human being, if you were witnessing that crime, you will be writing down, or you will try to report a lot of these things, like what kind of what was the gender of the person who committed the crime, what was approximate height of the person, build, what kind of hairstyle, if it was visible, what kind of clothing they were wearing, what kind of color of the skin, the complexion, ethnicity, and all this information is helps um, the law enforcement to go out and actually prevent any further crime committed by the same person. Now we are trying to build this into a computer or a camera which is already looking at the people out there, being able to see and record these information, because not every camera knows that this person who is walking on the street is John and the other person walking across is Mike or Ian. All they can do is, this is an average height, well built, bald guy, which is walking across and he just picked a pocket, right? So can we build that kind of things into a machine, or basically a camera, and make it fast enough so that it is in real time? Real time we consider is something that can be done in 20 frames per second. So within, we are able to analyze 20 frames in 1 second. A typical challenge with face detection, which leads into face recognition, is the best quality you get is if the person is standing right in front of you, has got no mask cover, and you are able to see various features or shapes of that person's face. If it is a sideways, then you're pretty much getting only half of the face to match. And once you get all the features, that's when you're trying to match things together. And that's where all the facial recognition works. That's how your iPhone or your smartphones are able to look at your picture, do a kind of short video of you, and trying to identify whether you are the right person who is allowed to access the system. So facial detection and recognition is quite a good example of how artificial intelligence is being used right on the edge devices, right on the end devices, which people are carrying in their hand, or portable devices, battery backed. But then there are other issues as well. As any kind of artificial intelligence, people try to find all kind of ways to fool around it. This is a typical example of where what led to something called as a liveness detection, so that people don't just put another person's picture and get a phone to unlock. You need to have something as a way to identify that this is a real person or whether this is an image shown to trying to fake or spoof into the system. So that is another challenge that we look and try to solve in using artificial intelligence. And another thing, so I think any talk right now is incomplete without the talk about COVID-19. And the next one comes in as a mask challenge is out there in the public, can we write a system which can actually real time do a mask detection? Whether that person is wearing a mask, first of all, that that person is safe, maybe to enter into a factory to start working in the early morning, or can that person be allowed into public transport? Depends upon the kind of lockdown we are following. But the bigger challenge with masks is that masks make all kind of facial recognition fail, because you cannot see the whole structure of the face. And as soon as the masks come in, then the whole things become quite challenging, and you need to adopt your existing artificial intelligence models to be able to handle uh, different kind of mask and different kind of shape changes. This is a good example of a person normally wears the glasses, but on that particular day, maybe he's not wearing the glasses. Should he be allowed to enter the office? And if that person is coming into the office with a mask and the glass, how do we do all these kind of challenges? So things have, over a period of time, they have become more complicated. AI is not just as simple as, AI was not never as simple, but AI has become quite complicated over time, and it has evolved as well. And this is just another good example of, this is exactly where open consulting does a lot of its work as well. It's more about combating anti-surveillance techniques that people are using. So the guy on the left, he is actually using a very simple mask which are available on eBay to purchase. And if that person is wearing that mask on a winter day in city of London, I barely believe that anybody would notice that this guy is not a real not a real face. And that would definitely lead to all of the facial recognition systems to fail on him. And what we are doing is enhancing all of our artificial intelligence models to be able to work even on smaller parameters, like just matching the eyebrows, matching the eye shape. uh, if somebody is wearing a balaclava and committing a crime, which is quite normal, I would say, in any kind of household burglary or any kind of petty crime that criminals just wear a balaclava, is we are currently working on a system which should be able to identify people even just based upon the eyes. Of course, it will not be 100% accurate, but it will be a good match, and we should be able to take things further. That's what most of my current research is mostly on. Um, Coming to a basic concept is, every industry, every application of artificial intelligence has got a very simple flow. On the left side, you have got some kind of IoT device which is capturing the data. It could be audio, it could be video, it could be two people talking on the phone and you're recording that audio, but somebody has to synthesize that data. Or it could be a video feed from 100 different cameras in your office, which are being captured, and then there's some kind of pre-processing needs to be done on them. That's basically reducing the noise, maybe reducing the uh, differences due to sunlight or due to trees moving, getting rid of that. And after that, you're actually doing the artificial intelligence of detecting, tracking. In technical terms, it's called inference. That's basically you're trying to infer some data out of it. And after that, it's just creating a metadata. It's up to you or your organization whether you want to upload it to the cloud or you want to process things locally. And the last part is the visualization or alerting or basically monitoring system. So a simple example, what we looked at before was the guy looking at hundreds of cameras on a CCTV screen. Instead of that person looking at so many cameras, artificial intelligence can be put into the cameras and into the monitoring systems so that only the suspicious activities pop up on the human monitor. Everything else is just getting recorded. And that's the main part that we work on, is from pixels, getting the insights. And if we follow the same rules, that's another thing that what we do is getting the maximum inference from even from the vehicle data. So we're building up tools which can help you in surveillance, or say if there was a crime outside your house while you were sleeping, the only way you could find out is you have to go back through the CCTV footage and utilize that to be able to identify the vehicle, which could be quite sensitive for human eyes to go through it. And what we work on is basically use AI to be able to identify the color of the vehicle, the type of the vehicle. So it could be a van, it could be a minivan, it could be a sedan, uh, the make of the vehicle, because most of the vehicles have got their own shapes. So BMWs don't look like Mercedes, and getting the number plate if you've got the right angle, and also being able to identify whether it is a parked vehicle or a moving vehicle, especially from a fixed camera. And we these things mm, change a lot depending upon whether you have got a fixed camera looking at an angle. Then you've got different things going on. But if you have got a camera which is sitting as a dash cam inside your car, then the models change a lot, because there is a lot of vibration which causes a lot of noise, and the focus changes continuously. So a lot of challenges which go into AI just on the video streams we are talking here. And it requires a lot of iteration to get a model which is perfect just on the server itself, and then trying to package it all together and pushing it down to the edge devices. It's a challenge in itself. So you might have seen that a couple of years back, we used to do these kind of things as use Raspberry Pi with, there could be a camera, which could be a CCTV camera, which is sitting outside your house, or it could be a Pi camera, which is just mounted on the device itself. And you can use some kind of, Pis are quite good devices, but they are not that smart, or they're not that powerful to do artificial intelligence on the edge. So there are a lot of solutions which have been put together. People just record the things on the camera, they send it off to cloud, and on the cloud, they do all the calculations, which tells them a result back. And that's exactly how Nest or any kind of your doorbell works, is they keep sending video images to the cloud to be able to identify things. But if you try to move it on to the edge, you will need some kind of a neural network, or basically a GPU, to do specialized calculation. So we were previously doing these kind of things as packaging things together, get a Raspberry Pi, get a camera feed, get a neural stick, just patching things together to create an edge-based computer vision solution, just so that we can avoid a trip to the cloud, and we are able to make a better decision on the edge itself. And as you can see on the right hand side, this is able to identify people with their names, matching the people, and also being able to identify the vehicles. Pi is not that smart enough or that powerful enough. There are various other combinations which are there. I mean, most of you guys might already know these kind of single board computers. So Movidius also provide a neural compute stick, which can be used with various Raspberry Pis or your computer. In the center, what you see is a Jetson Nano, which is another single board computer, which has got a GPU on it. So none of the Raspberry Pis have got a GPU inbuilt. The Jetson Nano basically inbuilt has got a GPU inside, and that gives tremendous power to do the artificial intelligence on the edge in a very small form factor, and getting the calculations in place. This is just a comparison of what Jetson Nano, Jetson range from, I'm not selling on behalf of NVIDIA, but these are the kind of devices that we have been experimenting and trying things out. On the left, we have got the cheapest, that's a Jetson Nano, and size-wise, this is just the chip itself is actually smaller than a Raspberry Pi. What you saw before in the middle is Jetson Nano SGK, which has got a heatsink, couple of connectors over there, but the one on the left over here is the actual chip, which has got a NVIDIA GPU, which is a 128 core GPU. And best part is the power consumption, that it can actually run from 5 to 10 watts, just on 5 to 10 watts of power. So it can be battery powered as well. And it's quite small in size. Then as you throw in more money, you get better power, more teraflops coming in for doing calculations. And this is the newest addition which Jetson has brought in, is called Xavier NX. When you look at the size, it's pretty much exactly the same as the Jetson Nano, but selling at $399, and is just recently launched, but it is 12 times as faster than Jetson Nano. So these kind of devices are purpose built for doing these kind of activities of artificial intelligence on the edge. And that's exactly what we experiment and work with most of the time going forward. So looking at, that's pretty much it. I know I was quick and not that detailed into each one of the things, but there's just a couple of projects which are there. On the right, what you're seeing is pretty much a quadcopter which is built with a Jetson Nano on it, and has got a camera in the front, pathetic battery life, but is able to fly and do autonomous, or maybe follow other people around. These are just a couple of other installations of a proper Jetson Nano with a camera out there with a big battery pack alongside, powering it up. And this is just concealed and done a proper job. That's a big battery pack which can run Jetson Nano for, or basically a power hungry GPU for 48 hours. So that's a big battery pack, which is quite heavy, but yeah, that's kind of pack goes as well. And this is just, it's not a full picture, but it's actually running on a bicycle. So that's just a brief upon using AI on the edge.